Okay, so now we're in chapter 5. Remembering that chapter 5 was all about ratios, there's also 6 lessons in this chapter. We only did 1 through 5. 1 through 5 will also only be on the final. So let's start with being able to write a ratio if you're giving a bunch of data. So over here we have ingredients for modeling clay. You have 2 cups of flour, 1/2 cup of salt, and 3/4 cups of water. So if I wanted to know what's the ratio of salt to flour, remembering you can write ratios 3 different ways. You can write them with the colon, which is what this is. You can write them as salt to flour, and you can put them as salt over flour, like a fraction. So if I want to know the ratio of salt to flour, I have 1/2 cup of salt for every 2 cups of flour, right? That's our ratio. I could also write it as 1/2 to 2. Could also write it as 1/2 over 2. All right? Making sure that you keep it in the order that it is in the problem. Next thing that was from lesson 1 is being able to fill out a ratio table. So I'm going to put a ratio table here, not the straightest line. And remember that the relationships in a ratio table are the same going up and down, and they are the same going side to side. What I mean by that is the relationship between this number and this number are the same relationship as this number and this number. And the relationship between this number and this number are the same as the relationship between this number and this number. So you can do it going across, or you can do it going up and down. I'm going to do it going up and down. So first thing, to get from 3/2 to 1/2, remember you want to multiply or divide when you're finding these relationships. So to go from 3/2 to 1, excuse me, to go to 1/2, I'm going to divide by 3, right? Divide by 3, you get 1. So that means here I'm going to divide by 3. That'll leave me with 1. Now here I have to go the opposite way. So if going down I divided by 3, going up I need to multiply by 3, which would give me 9/2. And here I would get 6. All right, so remember when you're figuring out a ratio table, just figure out the relationship between 2 of the numbers, and then you can use that same relationship to fill in the rest of the numbers. That's pretty much what we did in 5.1. In 5.2, we found unit rates. Remember, unit rates are ratios where one of the numbers is 1. So if I found out that there was a pack of pencils that was 12 for $2, right? The unit rate would be how much am I paying for one pencil? Remember, we did this when you guys were doing that whole activity where you were finding different things you were shopping for online. So, for example, let's say that I have 289 miles on 10 gallons. All right? So that's how many miles I can drive with 10 gallons of gas. I want to know how many miles I get per gallon. So what I would do, write this as a ratio, and I want to know, okay, when the gallons equals 1, what does that miles equal? And I can use the relationship here, or I can use the relationship here. All right? I think the easiest relationship would be the 10 to the 1 because we know that that's just dividing by 10. So if we divide by 10 here, divide by 10 here, we end up with 28.9 miles for every 1 gallon. That's how you would find a unit rate. Another thing we did in this lesson was tell whether or not two different ratios were equivalent. And what that means is they have the same difference in numbers. So for example, if I have 60 centimeters for every 2.5 years, and I had 30 centimeters for every 15 months, I need to figure out if that is the same. This is months, this is years, and these are both centimeters. Now, if I were just looking at the numbers here, I could tell, well, the relationship between 30 and 15 is just dividing by 2. That's definitely not the relationship between 60 and 2.5. However, this is in years, this is in months. So I need to make sure my units are the same before I compare them. So if I have 15 months here, how many years is that? Or I could say, how many months is 2.5 years? I like it that way because then I would be multiplying. So there's 12 months in a year. So if I want to figure out how many months is 2.5 years, I would just do 2.5 times 12, which would give me 30. So now I can rewrite this as 60 over 30 and 30 over 15. And look at that. The top number is twice as much for both of them. If I couldn't just see the relationship, I would actually have to divide those and figure out what I get. So over here, if I divided them, I would get 2. Over here, if I divided them, I would get 2, which means they're the same. These rates are equivalent. So moving on to 5.3. Here we introduced proportions. Now remember, proportions are when you have ratios and there's like an equal sign in the middle to show that the relationships are the same. You are going to have to figure out if these form a proportion or not. I'll give you an example. So 4/9 to 2/3. All right, you need to figure out if this is a proportion. One way you can do this is the relationship between the 4 and the 9 the same relationship as the 2 and the 3? Or remember, you can do the butterfly. If it's a proportion, those two numbers, if you multiply them, should equal these two numbers if you multiply them. So 9 and 2, if we multiply them, we can get 18. 3 and 4, you multiply them, you get 12. Nope, not a proportion. All right? So that's how you figure out if something is a proportion or not. You can do the same thing if you had a table. So for example, I'll put a table here. Let's say we have 1, 4, 3, 12, 6, 24, and 8, 32. And you need to tell me, are the numbers here proportional? Now you can do that either by figuring out what is the relationship between the numbers and if it's the same. So from 1 to 4, that's multiplying by 4. And from 3 to 12, that's multiplying by 4. From 6 to 24, that's multiplying by 4. And from 8 to 32, that's multiplying by 4. So from top to bottom, we're good. Now we need to go from side to side. From 1 to 3, that's multiplying by 3. From 4 to 12, that's multiplying by 3. So you could do this and go all the way across the table, or if it were me, I'd just set up a proportion, do what we just did, do the butterfly. 3 times 4 equals 12. 1 times 12 equals 12. We're good. All right, so that is proportional. Now moving on to lesson 4. Lesson 4 is when we used proportions to find values that we don't know. So for example, let's say we have 3/8 equals 9/x. And you want to figure out what's that x. And just in chapter 4, remember we were solving equations, so you remember how to find x. You can just move everything away from x. But with proportions, you can even do something even simpler. Remember with the butterfly, those two equal each other, and these two should equal each other if you multiply them. So 8 times 9 would give you 72, which is also x times 3. Divide both sides by 3, you end up with 24 equals x. Now, you could have also done this by figuring out what is the relationship between the 8 and the 3, and then use that relationship to figure out the x, the same way that we did a ratio table. I'm going to do another one of these. Let's say I have s plus 1 over 4 equals 4/8. I'm going to do the same thing. These two multiplied together equal these two multiplied together. So it's going to be 16 equals 8 times s plus 1. I need to distribute my 8. It's going to give me 8s plus 8 equals 16. Look, now it's an equation we just have to solve. Subtract 8. We're left with 8 equals 8s. I'm going to move it up here for more space. 8 equals 8s. Divide both sides by 8. We're left with 1 equals s. All right? So that's how you would do it if they gave you an expression somewhere on there. So now moving to lesson 5, which was the last lesson that we did. This is just being able to graph the proportional relationships. And remembering, if it's a proportional relationship, it always needs to go through the origin. And in case you forgot, the origin is that 0, 0 point right in the middle of the coordinate plane. So if I were to sketch a coordinate plane, this is our origin right there. So if I had some numbers that gave me a ratio table, x, y, -3, 6, -1, 1, 3, 2, -2, and -6. And I'm asked to tell whether it's proportional. How I could do that is I could either look at the table and figure it out that way. Are the relationships the same? If I were to cross multiply, would they equal out to be the same? Or if they gave you just the graph, though, and said, is it proportional, you would need to be able to tell by the graph. So, recap on how we use a graph. First thing we're going to do is remember this is the x line, this is the y line. So my x is -3, -3 is going to be over here. And then 6, this is my y line, 3, 4, 5, 6. Now this isn't going to be perfectly straight because I'm not using graph paper. I'm kind of guessing where the lines would be. On a test, if you were asked to use a graph, you would either be provided a section with graph paper or the graph would already be made for you and you just have to tell if it's proportional or not. Then we have -1 and 2, which is like here. Then we have 1 and -2, which is like here. And then we have 3 and -6. 3, 4, 5, 6, which is like here. So if I connect my line, it crosses the origin. Now, my line's not perfectly straight because I'm drawing on a computer. But if you were to trace this with a ruler, you can tell just by those 2 points in the middle, it would cross the origin. It's proportional. So that's the last thing we did in this chapter. So just being able to figure out your ratios and proportions, which is really important for chapter 6. So if you have any questions, let me know because it's important for the next chapter to make sure you remember how to do this one. That is all.